Okay, let's continue our discussion talking about ions. Ions are what happens when an atom loses or gains an electron. Okay, so if an atom gains an electron, let's take an atom of a neon, for example, or let's use chlorine, for example. Here's an atom of chlorine. If chlorine gains an electron, it has more than it started with. Look at this atom, Fred. How many protons and electrons does it have?
Oh, I know how to do that. I need the periodic table, though.
All right, so I'll bring up the periodic table and we'll take a look. Here's chlorine.
Okay, it's 17 protons and electrons.
All right, it has 17 protons and electrons. 17 protons and 17 electrons. Good. If I give it an extra electron, how many electrons is it going to have?
18.
That's right. So if this species has 18 electrons and 17 protons, notice how it has more negative charge than positive charge, one more. And we're going to indicate that with a negative sign like that. All right, so now this is not an atom, this is an ion, right? Chlorine atom, and this becomes the chloride ion. And we name it the chloride ion because of its location on the periodic table. It is a, what do you think? Is it a metal or a non-metal?
Chlorine?
Yeah.
It's a non-metal.
That's right. Chlorine is a non-metal. It's to the right of this staircase, right? So a non-metal, when it becomes an ion, we end it in the suffix "ide," like chloride ion. And this is kind of easy to remember because most of you have an understanding that this compound is called what, Fred? You remember that one?
That's just sodium chloride.
That's right. Notice how you didn't call it sodium chlorine, even though that's sodium and chlorine coming together to form this new compound. You called it chloride. And so you can remember that ions and sodium chloride is an ionic compound. So ions that are nonmetals end in "ide." Okay, very good. So ions have an unequal number of electrons and protons, and for that reason have a charge associated with them, right? Okay. So when I have a metal or an element like sodium, which is a metal, right? Here I'm going to bring it onto the periodic table, or bring on the periodic table so we can see it. 11 protons and 11 electrons, right, Fred?
Yeah.
If I take away an electron from sodium, how many, so let's say 11 protons and 11 electrons. If I take an electron away, how many electrons is it going to have now?
Just 10.
Right, just 10 electrons. And the result would be 11 protons and 10 electrons, and it'd have more of a positive charge. So I indicate that by putting a positive charge up there by the sodium. Okay, so this is called the sodium ion. Notice that I didn't call it the sodiide ion. For metals, we just keep the name of the metal and just call it the ion, right? Sodium is a metal, so it's called the sodium ion, all right? And in sodium chloride, I can say sodium chloride is a compound made of the sodium ion and the chloride ion. All right, two ions came together to form sodium chloride. Okay, now, ions that have a negative charge are called anions, and ions that are positively charged are called cations, and we need to remember that, okay? So I have a little joke to tell you to remember it, okay?
Oh, good. I love jokes.
Okay, good. You're going to love this one, Fred. There's a dog and a cat, and they're going to a restaurant, and they walk in, they sit down, and the dog says, "Are you feeling okay?" And the cat says, "I think I'm sick." And the dog says, "How do you know?" And the cat says, "I'm positive."
Is that it?
That's it.
That's not a very good joke.
Okay, well, whether it's a good joke or not, it's going to help you remember. What is it going to help you remember?
I guess that cations, because the cat was positive, cations are positively charged.
That's right. Cations are positively charged, anions are negatively charged. All right? So, metals form cations, nonmetals form anions, And we can look at the location of either metals or nonmetals on the periodic table and predict what kind of ion we would expect them to form. And that's for some of our metals and nonmetals, our representative elements. It was a while back that we talked about representative elements, Fred. Do you remember which ones are our representative elements here?
Not really.
Well, it was these first two columns and these last six in this box here. They represent a certain handful of chemical rules really well. And this is one of those rules that they represent really well. Based on their location of the representative elements, you can predict pretty well, for most of them, what the ionic charge is going to be. And the way you do that is by look at the number of protons and electrons that they have and compare that to the number of electrons that the noble gases have. All right, the noble gases, these noble elements, are stable. All right, they have a significant amount of stability associated with them, and because of that, they don't want to share electrons very readily with other elements. And it turns out that if you have either 2, 10, 18, 36, 54, or 86 electrons, 118 in the future, right, when we find that element, that your atom, your situation becomes significantly more stable, okay? And so, for example, fluorine, how many electrons does fluorine have?
9.
Good, 9 electrons. And if it had one more electron and could have the electron configuration of neon, all right? Electron configuration is essentially a way of saying the same number of electrons as one of these noble gas. That's called a noble gas electron configuration. If fluorine gained one extra electron, it would have a noble gas electron configuration. Noble gas electron configuration of neon, and that would provide a degree of stability. Okay? So, fluorine, chlorine, bromine, iodine, all of this family, do you remember what we call this group right here?
The halogens?
Very good. Those are the halogens. The halogens, if they gain one electron, they obtain a noble gas electron configuration. All right? So because of that, we can predict that an atom like bromine, for example, bromine is one of our halogens here that we're talking about. Bromine, when it forms compounds, it's not surprising that it likes to gain an electron and create the bromide ion. All right? Because it has 35, and it would like to have 36 electrons to attain a noble gas electron configuration. We can do that with all of these nonmetals here. We can also do that with the metals over here. Calcium. How many electrons does calcium have?
20.
Very good, 20 electrons. And the nearest noble gas, how many electrons does it have?
You mean like argon has 18?
That's right. Argon has 18, neon has 10, and krypton is 36, but calcium is closest to argon. So if calcium wants to attain a noble gas electron configuration, how does it do that?
What does that mean again, attain a noble gas electron configuration?
To have a noble gas electron configuration is just a fancy way of saying to have the same number of electrons as one of these noble gases. So if it has 20, what can it do to have the same number of one of these?
Lose 2 electrons.
That's right, lose 2 electrons. That'll give it a noble gas electron configuration similar to that of argon. All right? So when calcium loses 2 electrons, what is the resulting charge that we'll see on the calcium ion?
If we lose 2 electrons from calcium, is that going to be a 2 minus?
Calcium ion, how many protons?
20.
Very good, 20 protons. How many electrons?
20.
20 electrons, that's in that atom, right? If we lose 2, now we're going to a situation where we have 20 protons, lose 2 electrons, that is, and 18 electrons. I've lost 2 electrons. Now, when we lose 2, in your mind, you think, oh, minus 2. And so you want to do something like minus 2 on that atom. Put a minus 2 up here. But the minus 2 is trying to show you that there is a net negative 2 charge because of this imbalance between the number of protons and electrons. So the calcium ion is actually going to be that sort of a thing, a 2 minus charge. Or if we like to write it like that, it's 2 minus charge, okay? All right, good stuff. So we can predict that calcium is going to have a +2 charge simply because of its location on the periodic table. All right, so look at the periodic table, Fred, and identify what kind of an ion you think, what kind of a charge atoms of sodium are going to have when they form ionic compounds, when they form ions.
Sodium?
Yeah,
Okay, so I look and see that it has 11 electrons and protons.
very good,
And neon is its closest noble gas neighbor.
very good.
So it wants to have 10.
That's right,
So it wants to lose 1 electron.
very good. So if it loses an electron, what is the resulting charge?
If it has 1 less, then it has 11 protons, it has 10 electrons. So that's a +1 charge.
Very good. So that's why we know, based on its location, that sodium is always going to have a +1 charge. And you can extrapolate this understanding to see that all of these, when they form ions, are going to have +1 charges, and all of these, when they form ions, are going to have +2 charges. This is our alkali metals, and these are our alkaline earth metals. Alkali metals have a +1 charge when they form ions, and alkaline earth have +2. Halogens have -1s. Very good. Now let's look at nitrogen. Nitrogen. Do you think you can figure out what kind of a charge nitrogen will form based on its location?
It has 7 protons and electrons.
Good.
And neon, is it the nearest one?
Let's see. 8, 9, 10. Or if we go backwards, 1, 2, 3, 4, 5. Yeah. So 10 is the nearest noble gas electron configuration for nitrogen.
So it's going to want to gain 3 electrons.
Gain 3. So does that mean I put a +3 on there?
No, because you're not saying how many it lost or gained by putting the charge on there. You're saying what the resulting charge is.
Very good. So the neon's resulting charge, nitrogen's resulting charge is going to be what?
-3.
Very good. A 3 minus charge is the resulting charge when nitrogen forms an ion. How about oxygen?
-2.
Very good. Oxygen has 8, wants to have 10 electrons. Gaining those 2 electrons will give it a 2 minus charge. Excellent. All right, so now with you and your neighbor, you guys should, or if you're alone, fill out this table, right? Fill out this table, push pause, fill it out, identify the number of protons, neutrons, and electrons in these different species. From the given information here, identify what this missing symbol is for you, okay? Push pause, take your time to do it. All right, hopefully you got it done. Make sure you take time to do it. What do you think, Fred? How many protons?
Looking at cobalt on the periodic table, I guess it's 27 protons.
Very good, 27 protons. And how many neutrons?
Oh, I just saw it, it was 33.
Okay, so if you didn't see it, how would you know?
That 60 is the sum of the protons and neutrons.
That's good, that's called the mass number. So 60 minus the number of protons, 27, would be the neutrons, which is 33. How about the number of electrons?
Well, +3 doesn't mean 3 more electrons, even though that's what I want to think.
Good.
+3 means that it has 3 less electrons.
Okay, good job. So it means it has 24 electrons?
Yeah.
Good job. All right, how about this species over here?
Bromine, where's it at on the periodic table? There it is, 35.
So 35 protons. So how many electrons?
18 minus the 35.
Very good. 18 minus the 35. 81 minus the 35, right?
Yeah.
Very good. So I have 46 neutrons and 35 protons. Now, what about electrons?
Same as wait, no, it has a negative charge on it. So one more than 35.
That's right. 36 electrons. Very good. How about this symbol right here?
29 protons. What has 29 protons?
Let's bring up our periodic table and take a look. 29. Wait, how did you say 29? Oh, 29 protons, yeah. 26, 27, 28, 20. Copper. Copper has 29.
All right, it's copper. And then it has 36 neutrons, so the 29 plus the 36 would give us the mass number.
All right. So 29 plus the 36. So it's copper 65.
Yeah, that's right, and we did that one before. I remember that. Copper 65. Now the number of electrons is 27. That means it's 2 more protons plus 2. So copper 65 with a plus 2 charge.
Very good. Copper 65 with a plus 2 charge. Fabulous work.